Yes, good afternoon. This is another experiment which is PN diode to find the forward bias characteristics. So just look at the connection. We have got from the power supply, it is to be our power socket, it is to be connected to the diode. It is connected like this. So actually, we have got a box like this. This is a diode setup. You can see this is the voltmeter. Okay, and this is the ammeter. It is a milliammeter. Milliammeter part is what you could use. See, if you look at the voltmeter and ammeter, you can see one thing. The readings are, there are two sets of readings given. It's 0 to 3 volt, one reading, one range, and the other range is 0 to 30 volt. That depends on which scale you will use. That depends on which knob you are selecting. See, you can see there is a knob here just close to this which can be selected as, see, this is the one, 30 volt DC and 3 volt DC. Okay, so for forward bias characteristics to study, we need to select this knob, that is towards 3 volt DC. Okay, make sure first it is at 3 volt DC. So that means we are supposed to use the scale, the range, the top one you could use, that is 0 to 3 volt. I hope it is clear, 0 to 3 volt. So that you can see the one division, 10 divisions are further divided into 0.5. Sorry, 0.5 is further divided into 10 divisions. That means one division is 0.05 volt. One division, that is least count as 0.05 volt. Okay, 10 divisions, when there is a deflection of 10 divisions, you should read it as 0.5 volt. Similarly for ammeter, you know, in forward bias characteristics, the readings are in milliamperes, whereas in reverse bias only it is in microampere. So milliampere or microampere, that depends on which kind of biasing we are doing. We are doing forward biasing, so we are supposed to use only the milliampere one, that is 0 to 10 ampere, the top one. So in this scale also, in ammeter also, the one to use is the above reading written above the scale, that is 0 to 10. So in that you can see in the milliammeter, the first 10 divisions correspond to 2 milliamperes. That means one division here is 0.2 milliampere. That is the value of one division. One division is 0.2 milliampere. So that is how the milliammeter is set. Okay. So when you start with, you know, you have to select ammeter and voltmeter range also. So here again 3 volt, 30 volt. So we are selecting to 3 volt. And also here we have which one to use in milliampere or microampere. We are going to use microampere. That is both you should shift to up. Okay, 30 volt, 100 microampere is not what is selected. So you have to select the top one, that is 3 volt and in milliampere. That is how many milliamperes? 10 milliamperes. Okay, then we can use the corresponding scales in the 2 meters as well. I hope it is clear. So to begin the connections, where we can start with this, you know, a simple circuit diagram, you can this is how we draw a simple circuit diagram for the PN diode in the forward biased condition. Now I will show you how to connect. So you start from the positive terminal of the battery. See, this is the battery. Okay, you know, the rheostat, what is shown, usually shown is what is shown here with a knob. This is the rheostat. Okay, this is what you will use for repeating the experiment. So you start your connection from the battery. So you can see in the circuit diagram, the battery's positive terminal. Where is positive terminal connected to? It is connected to P type, and also it is connected to the positive of the voltmeter. So like that over here, this is positive terminal of the battery. Okay, where is it connected to? It is connected to, see, do one thing. So you can make out one thing, both are positive terminals only. The red one is positive terminal. These both are negative terminals. Okay, so you connect the positive terminal to the P type. Okay, positive terminal to P type. One connection is made. So learn it carefully. Then what else is, you have to again connect one more from positive terminal. See, this is also positive terminal. Where is positive terminal connected to? You can see in the connection diagram. Positive terminal from the battery. First I connected it to the P type, and then it is also connected to the positive terminal of the voltmeter. See, this is the positive terminal of the voltmeter. So positive of the battery connected to positive terminal of the voltmeter. Okay. Then what else is, you just see, look at the diagram, circuit diagram. The N type is connected to positive terminal of the milliammeter. Okay. And negative terminal, okay, well, let us first connect N type to positive terminal of the voltmeter. So I am taking another wire. This is N type, you can see this is N type. Where is N type connected to? N type is connected to the positive terminal of the milliammeter. See this one. Positive terminal of the, not voltmeter, positive terminal of the milliammeter. You can see, once again I will show you the connection. N type to the positive terminal of the milliammeter. Okay. Then where is negative terminal of the milliammeter connected to? Negative terminal is connected to, one second, yeah. Negative terminal is connected to two places. Okay. One is negative terminal connected to negative of the voltmeter. Negative terminal is connected to negative of the battery. So negative of the battery, see any one of these terminals you can choose. Negative of the battery to the negative terminal of the milliammeter. So what I will do is, I will just do a connection like this, just look at this. From here we can connect two. So I am connecting one to this. So negative terminal of the milliammeter, one terminal is connected to the negative terminal of the voltmeter. Okay, that is connected to negative terminal of the voltmeter. Okay, just 1 second. Yeah, I have connected it to negative terminal of the voltmeter. See, negative terminal of the voltmeter, then negative terminal of the milliammeter. See, that's what is shown here. Okay, this connection. Then again negative terminal of the milliammeter. See this one, negative terminal. One more wire is there now. Okay, that is connected to the negative terminal of the battery. Negative terminal of the battery. See, it just connected to one of these terminals. You can connect negative terminal of the battery. See, what I have connected is negative terminal of the ammeter to negative terminal of the battery. Okay, this is the connection. I hope you understood the connection. So you can again rewind and see how the connection is being done. So to start with, you ensure that this knob is at 3 volt. This is at 10 milliampere. Then this is also selected to 3 volt. Okay. After that, okay, it came out. Okay. So you ensure that the negative terminal of the voltmeter and negative terminal of the milliammeter connected. Okay. Now switch on this part, then switch on this knob. So you can see that's you can see the indicator light. You switch it on. Okay. That's it. Then after that, what you should do is just use this knob. Okay. This knob you use and measure for different voltages. See, measure, maybe this is 0.25 volt current, no current, no. So like that, different voltages, you measure the corresponding currents. You can see the current is, I think it would be better, you start with 0, then point, what is it, 0.5, 0.1, 0.15, 0.2, 0.25. So like that, if you take throughout, this current will remain 0. Then like that, if it is kept on increasing, the voltage kept on increasing, you can see the current starts increasing from here. You can measure the milliammeter reading. So for example, if the millimeter reading is here, how much is the millimeter reading? Just 1 milliampere. 1 milliampere. Okay, so like that, for various voltages, measure the corresponding currents like this. Okay, that's experiment, and based on that you can draw a graph between voltage and current. The graph you can, you might have observed it, might have seen, if you plot a graph between, current on the y-axis and voltage on the x-axis. This, remember, this current is supposed to be in milliampere. So at the beginning you have seen current is not increasing with increase in voltages, and at one value you can see that current starts increasing. This is how the shape of the graph is. This is called forward bias characteristics. So at around this particular voltage, the current starts increasing. This voltage, how much ever it is, you just note it down. That voltage is what is called knee voltage. Okay, the minimum voltage required for increase of current in forward bias condition, knee voltage or threshold voltage. Okay, hope it is clear. That's all about the experiment on diode. It's very simple. It's all already all these are built in. So you just need to put the connections like this. Okay, hope you understood. If it is to be clarified further, you can watch it again and again and learn the connections properly. This is how it will look like. Okay, always you refer your circuit diagram and do the connections. Thank you.